Assalamualaikum. My name is Nik Farhain binti Nimat Yusuf and my metric number is 071958. Today I will presenting our case study titled Predicting Student Performance Using Classification Technique in WECA. This project explores how data mining can be applied in education domain, specifically to help predict student academic performance. For this purpose, we use classification as our main data technique since our goal is to categorize students based on their performance, such as pass or fail. We test three classification models, naive-Bayes, J48 decision tree, and random forest, all using WECA. In the next slide, I will explain each model's performance strength, limitation, and how it can support better decision-making in education. Here is the naive-Bayes model. It gave us an accuracy of 67.71% and its AUC was 0.85. Naive-Bayes is very simple and fast algorithm. It works well even with small dataset and easy to understand. However, it assumes that all features are independent, which might not always be true in student data. Still, it can help teachers and admins make quick decisions like identifying at-risk students early. The second model is J48, which is a decision tree. It achieves 75.83% accuracy and an AUC of 0.84. J48 is good because it produces a visual tree that clearly shows how decisions are made. It works well with both numbers and categories, but it can sometimes overfit, especially if the data is messy or too small. This model is helpful when we want to explain why a student is predicted to pass or fail. This is the random forest model. It had the highest accuracy at 79.97% and AUC of 0.90, and it also highest among all the three models. Random forest combines many decision trees to get better and more stable results. It's great for complex student data and it avoids overfitting, but it's not easy to explain and it takes more time to run. This model is useful when predictions accuracy is most important, like for selecting scholarship students.
Assalamualaikum, my name is Khadijah Safia binti Atib and my metric number is 073739. So I will be presenting part B, which is data preprocessing and feature selections. Why data preprocessing is important? Data preprocessing is a crucial first step before training a machine learning model. It involves cleaning the data, handling missing value, and convert the data into a format that the machine learning algorithm can read. This process is to ensure that the dataset is complete, consistent, and machine readable, which is very essential for building an effective and accurate model. There are two main pre-processing steps that we focus on for this project, which is handling missing value and string to nominal conversions. First is to handling missing value. Some attribute in the dataset, such as parent answering survey and gender, may have missing or zero value. This missing value could skew the model prediction if it left unintended. To handle this, we replace the missing numeric value with the mean value and missing categorical value with the most frequent value. This to make sure that our dataset remains complete and the model training process isn't disrupted by missing or inconsistent data. Second is the string to nominal conversions. Some columns such as gender, nationality, and topic in our dataset were in string format, which many machine learning algorithms cannot process. So, to address this, we convert this string value into nominal categories. It makes it easier for classification model to handle the categorical data and improve the model ability to make accurate predictions. And lastly, we have feature selections. And so here is the most important feature based on the correlation that we choose, which is raised hands, visited resources, discussions, student absence days, parent answering survey, age, gender, and nationality. Why do we choose this feature? Because it is strongly correlated with the student performance, and it also helps the model to distinguish between high, medium, and low performers. And it also removes irrelevant features to reduce any noise and improve the accuracy.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Nur Murshida binti Arawaruna alias Muhammad Muzir, matrix number 071891. So I'm going to be presenting the part C of the case study, which is final model selection and its justification. So here is the summary table of those three modules result, which is J48 decision tree, naive Bayes, and random forest. So as you can see, the chosen best classifier is random forest. So this is because the random forest has the highest accuracy, which is 76.67%, and has the best AUC score, which is 0.897. So that means it's good at both making correct predictions and distinguishing between low, medium, and high classes of students. So it also works well with our dataset, which has a mix of categorical and numeric features. So to ensure that stakeholders trust and adopt the model, which is random forest, we propose several key steps. First, we have transparent reporting, which will use accuracy, AUC, and confusion metric results. So this will build confidence in how well the model performs. Next, we have explainability, so it will use feature importance and example predictions. Next is pilot testing with actual academic data before full deployment. And lastly is feedback loops. So this will allow teachers and administrators to review and give feedback on the predictions so that it will help to improve the system over time. While the model offers great benefits, there are also ethical considerations we must address. So first is student privacy. We must ensure data is anonymized and securely stored to protect the student's information. Next is bias detection, where we should evaluate the model for potential bias based on gender, ethnicity, and etc. Next is informed use, where we should clarify that the model supports decisions, not replaces human judgment. And lastly, we have transparency, where we must clearly communicate model limitations to the stakeholders so that the stakeholders don't over-rely on it or misinterpret the results. So lastly, we will be addressing implementation challenges and its solutions. So the one common issue is resistance to AI tools from staff who are not familiar with data science. So to overcome this, we propose to provide training sessions and clear documentation to help them understand the model and its use. Next is data quality issues. So we must ensure pre-processing and cleaning steps are validated. And lastly, to keep the model relevant and trustworthy, we recommend continuous monitoring. So by regularly retrain and audit the model for consistent performance. So that is all from us. Thank you.